There's a correction for the previous problem. Sorry, I made a mistake, so I had to go back and do it again. This is a piece of wood floating in water. So the blue stuff here, that's the water, and some is below the water, most is below the water, a little bit is above the water, as you can see right there. So we're talking about something that's floating in the water, and this is Archimedes' principle. Since it's floating, the weight of the object, mg, is balanced out by the buoyant force which pushes up. Of course, the buoyant force is equal to the weight of the water that is pushed out of the way. Fresh water, salt water, whatever it may be. In this problem it says it was salt water. So we have the weight of the wood. The weight of the wood is equal to m times g. The buoyant force will be equal to the mass of the fluid times g. And as you can see, g will cancel out. Now let me slow down so you guys have a chance to observe that, get a feeling for it. This upward force right here, that's the buoyant force, or I'm from Philadelphia, buoyant force, balance out the weight of the object, so therefore the object can float, okay? So here's the weight of the piece of wood. It's the mass of the wood times g, the buoyant force equal to the mass of the fluid times g, but g appears on both sides of the equation, so that cancels out. Now, what is the mass of the object equal to? Well, it's equal to the density of the object times the volume of the object. What's the mass of the fluid equal to? It's equal to the density of the fluid times the volume of the fluid. So let me slow down again. How do I figure out the volume of the object? Well, it's equal to the length times the width times the height. That's the object, okay? So that's going to be 10 centimeters this way, 5 centimeters that way, and 2 centimeters that way. So it's 10 centimeters times 5 centimeters times 2 centimeters. Now the volume of the fluid that's pushed out of the way will be equal to this length right here, times that width, that right there. But the fluid only goes up to 1.3. 0.7 of it is above the water. So we have actually, it's a little bit scribbly here, but it's 10 centimeters times 5 centimeters times 1.3 centimeters. So we have the 10 centimeters will cancel out, the 5 centimeters will cancel out from both sides. So we end up with the density of the object times 2 centimeters equals the density of the water, salt water, times 1.3 centimeters. And when you do the calculation, you'll find the density of the object is 666 kilograms per cubic meters. And since it's less than some water, it will float. And that's Archimedes' principle. Okay.